5, 4, 3, 2, 1.
The final two missions will investigate getting our payload to the moon by looking at how rockets blast off and how they are designed to carry a payload. Dame Zaha Hadid received many awards and prizes throughout her illustrious career for designing some of the most iconic buildings in the world. In many cases, she was one of the first women to receive those prizes. Her work is instantly recognisable for its futuristic look, the incredible curves and those really high vaulted ceilings, which is actually something that will be really useful for the mission later on. Her designs in the UK include the Aquatic Centre in London, built for the Olympics in 2012, as well as the Riverside Museum in Glasgow, Scotland. Her designs also include the Evelyn Grace School in southeast London. Rockets work on the principle of propulsion by generating a force that moves an object forward. This can be done by suddenly increasing the volume of one of your component parts. For example, if you have a compressed component such as a spring or compressed air, NASA fuels its rockets with liquid hydrogen because not only is it the lightest element in the periodic table, hence its low density, it also burns extremely hot, 3,000 degrees centigrade, and also expands rapidly, which is fantastic for propulsion because liquids take up a lot less room than gases. And so this rapid expansion, in addition to the high temperatures expanding the surrounding air, provide a huge propulsion forward by pushing down on the Earth, which pushes the rocket upwards. We're not going to use liquid hydrogen for our rockets. We're going to use a different chemical reaction. So now we're ready for the experiment. We need somewhere with lots of space, somewhere either outside or with really high ceilings. Now, what do we need for this experiment? So we've got some pipettes, some water, the film canister and a lid that fits, your effervescent fizzy tablets, safety goggles, and if you like, you can even decorate your canisters for launch. Safety goggles on, canister ready. I'm going to fill it with about halfway with water. Get half a effervescent tablet and the lid ready. Here we go. Pop it on really tight, turn it upside down. Woo!
Brilliant.
So what do you think happened inside? And why do you think the rocket took off? Try different ratios of fizzy tablet water and see how high you can get a rocket to go. Here's a question. Would you change both things at the same time, or would it be better to just change one thing at one time? Why? Do you think if we change the ratio of water to effervescent tablet, that we could get it up to the ceiling of one of Zaha Hadid's buildings? How high do you think it could go?
No.
Should I do another one?
Yeah. Oh, no, there we go.